Hi, in yesterday's video I said I would explain redshift, which I will attempt to do, and a friend asked me how big is space, so I'm going to try explain the size of the universe. So redshift, this starts with needing to understand frequencies. So electromagnetic radiation, that's the light that we see, visible light, infrared, ultraviolet, gamma rays, x-rays, radio waves, all travel as waves. So one wave is an up and down and back again, and that's one wavelength. And you get however many wavelengths you have in a second is your frequency. And the different types of radiation each have different frequencies. That's how we can detect them and tell them apart. So these waves travel around the universe and we can detect them. They're emitted by stars and everything that emits radiation in our universe. Let me start with the Doppler effect. That may make it easier to understand. So you've all heard when a siren, like a police car or an ambulance, as it's coming towards you, the pitch changes, and then as it moves past you, the pitch changes again. It almost gets louder, 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 softer, softer, softer. And that happens, say, if a motorbike was traveling very fast past you, you would hear that as well. That's called the Doppler effect. That's when two things are moving relative to each other and the waves between them change. And this effect is called the Doppler effect. So in space, if you can imagine us and a star that's emitting light, we're moving relative to each other. So there's a Doppler-like effect, but it's happening with the light that's being emitted. And the wavelengths of that light, as it travels further, are stretching out and becoming more red because its frequency is changing as it stretches out. And so we call that the redshift effect. Even if we weren't moving relative to each other, that star and Earth, we would still experience that because we're actually moving apart all the time because the universe is expanding. I hope that made sense. I'm not sure I explained it the best way possible. But that also goes towards understanding the size of our universe. So we imagine the size of our universe as spherical. There was the Big Bang and everything started moving out in all directions. And we know that as it's expanding at an increasing rate. So we're expanding apart faster and faster. So using things like redshift and detecting stars, importantly detecting the different types of stars. We know that blue stars are very young stars, white stars are sort of middle-aged, and red stars are old stars. And so we can detect the different ages of stars and how far away they are, and we can work out these distances. And then if we add to that calculation the fact that we know that the universe is 13.8 billion years old, we can figure out how far it is from us to any edge of the universe. And we imagine being spherical, that it's the same distance in any direction. We've calculated that to be 46 billion light years. So again, light travels from the sun to the earth in 8 minutes. That's 90 million miles. Now imagine how far it travels in 1 year. And so if we take one end of our universe to the other, that's 96 billion light years across. The problem is that's as far as we know and can see, and we can't see beyond that. So we're assuming that's the size of the universe. Because our universe is expanding faster than the speed of light, we can't see past the edge of our universe, the part of the known universe. So we're not entirely sure how much bigger it is on the outside of how far we can see, but we do know for definite it's at least 96 billion light years across. Hope you found that interesting. Let me know if you have any more questions, and have a good day and stay safe.